Good evening, everyone, and welcome to Science Pub, where we're taking research from the top minds of Oregon State University and connecting it with our virtual friends and community members. My name is Nathan Moses, Assistant Director of Events and Engagement at OSU-Cascades, and I thank you again for joining us tonight. We'll be joined in short order by tonight's presenters, Erika Wolters and Brent Steel, but let's get to a few updates before we dive into tonight's program entitled, When Ideology Trumps Science, Why We Question the Experts on Everything from Climate Change to Vaccinations. First up, for everybody that is new to our presentation, we will utilize mentimeter.com, so www.menti.com, for our audience participation at the end of the presentation for question and answers. Those of you that are logged into YouTube, you can also shoot us questions there. We'll make sure we moderate those throughout the night. But if those of you that would like to use the Mentimeter app, you're going to input event number 4384064. That's 4384064. We'll put a couple reminders up throughout the show. If you don't have your questions answered, because we have been getting a lot of them lately, please feel free to email us at events@osucascades.edu. Next up, we've got some special updates and announcements from OSU. So first up, we do have some upcoming science pubs. We have this presentation tonight and 3 more coming up before the end of March. Take a look at those slides up there on the screen right now. We'll do a reminder at the end of the show, but make sure to mark your calendars and stay tuned for registrations that will be live here in the next week or so. And remember, you can always check out the event at your own convenience via our live streams. The Beaver Caucus, looking to be an advocate for OSU. Well, the Beaver Caucus is looking for you. Join us today and help support projects like the OSU Arts and Education Complex and the continued expansion of OSU Cascades campus here in Bend. Check out thebeavercaucus.org for more information on how you can be a part of it. Join OSU in celebrating the 2021 Stone Award for Literacy Achievement Literacy Achievement on Thursday, April 29th at 7:30 p.m. For more info, check out the link provided. You can also find it at beav.es/O89. Need a one-stop shop for all your fellow Beaver Nation alumni? Look no further than the Beaver Lodge and engage with and stay connected through athletic highlights, faculty research, enrichment activities, alumni events, and fun for the kids. Find out more information at osualumni.com/lodge. And finally, we do have an event coming up on February 23rd. Come learn about one of the most amazing travel opportunities coming up in 2022 during the event Tulip Time with Mayflower. This alumni excursion put on by the OSU Alumni Travel Program gives participants the opportunity to travel the second longest river in Western Europe and some of Europe's most historic sites. Learn firsthand experiences of just how amazing this program is before you even commit to the program. Find out more by visiting osualum.com/travel. And finally, those of you that have been joining us early, we had a lot of folks in the waiting room tonight, and as our typical tradition is, we do a little bit of a quiz. Now you're kind of grading yourself on this one as opposed to being in a live event, but we're gonna run through those. Some of these were pretty tough, and if the answers were anything like the content of tonight's presentation, which that's where they come from, so they should be, I think we're in for a really good presentation tonight. So we're gonna go through those slides one at a time now to answer those questions. The first one, what was the name of the award for wasting public money given in the 1970s and 1980s by Wisconsin Senator William Proxmire, who often criticized scientific studies? The correct answer for that was the Golden Fleece Award, which I'm sure we'll hear about tonight. Question number 2. In 2015, the Pew Research Center found that scientists and the public were divided on whether or not it's safe to eat genetically modified foods. The difference they found was, correct answer A, 51% to 88% for scientists versus 37% for the public. Question number 3, the term genetically modified organism refers to, correct answer is B, plants and animals that have had genes from other organisms inserted into their genome. Question number 4, in 1998, a paper by Andrew Wakefield, a British doctor, was retracted by the journal The Lancet, and the author had his medical license revoked for unethical behavior. The Wakefield paper claimed to have found that A, childhood vaccines were linked to autism and colitis. And last trivia question, see if you got 5 for 5 on this one. Let me know in chat if you did. Despite overwhelming scientific agreement that climate change is real and caused by humans, surveys of US public attitudes show that D, all of the statements above were true. All right. So those are trivia questions. Let me know for our YouTube viewers if you happen to get all those right, just out of curiosity. We used to do awards when we were live. Hopefully we'll get back to that within the next year or so. So let's keep our fingers crossed that everything's working. All right, so we're gonna get away from Nathan doing his intro and into the stars of the show tonight. Thank you for playing along with the trivia. Let's get to Erika and Brent. So Erika Allen Wolters is an assistant professor of political science and the associate director of public policy undergraduate program at Oregon State University. And Brent Steel is a professor of and the director for the public policy graduate program at Oregon State University. Now, in addition to the topic of this presentation tonight, in written form, Erika and Brent have also most recently worked together on a number of projects, but most notably co-authored the book, The Environmental Politics and Policy of Western Public Lands, which was just out this last year. So you should check that out after the presentation because they are captivating presenters and they have some really interesting work. So without further ado, and on behalf of the Science Pub crowd, I'd like to welcome you both to the presentation tonight, and away you take it.
All right, thanks, Nathan. So I'm gonna start tonight, and Eric and I are going a little rogue tonight. So what we're gonna do is we're gonna cover some previous research that we've been conducting with colleagues at Oregon State University for literally the last 20 years on the role of science and scientists in the policy process, which mostly dealt with natural resource and environmental issues. And then we're gonna segue into the more recent work where we applied the methods that we used in these other studies to more social and economic issues. That is the product of our book. So I'm going to try to get the screen going here. Okay. Okay, and so we'll start out with this theme of science, scientist, and the policy process. And then we'll about halfway into this, then we'll move over to Erika, where she'll talk more about the recent book on looking at controversial issues. And so so in recent years, it's been clear that that science and scientists are no longer held in such regard on a lot of different issues and considered unquestioned authority sources for credible information in many high-stake policy debates. And just to lay this out now, when we did this research, was at a different time, and neither one of us would have dreamed we'd have been in this situation. So a lot of given this last year, so a lot of the things we're going to talk about may be a little understated when we get to the book. And I'm also going to say the book title. We actually got the book title. Some of you on here are probably have been involved in book projects before, but we had to come up with a title, and the title came up before the Republican primaries and before Trump won the primaries. So that's just to let you know about that. And so, in a lot of variety of issues, there's just a lot of questioning going on, a lot of polarization, a lot of ideological interpretation on a lot of issues such as climate change, GMO foods, immunizations. Of course, that's going on big right now. I don't know if some of you saw the article in the New York Times yesterday looking at the demonstrations at Dodger Stadium, people going up to get their shots. Birth control, all these things have led to increasing controversy the last few years. And it creates a lot of issues for coming up with public policy where science is involved. And some of the examples, and this one's a little dated here, but Governor Brown in California signed a law that was protested from the right and the left. Some people on the right and the left limiting personal exemptions against vaccinations. In Texas, there's support for abstinence-only sex education, while at the same time there's upsurges in sexually transmitted diseases. And across the nation, at local, regional, state, and federal level, many Republican conservative candidates for office deny that climate changes exists to appeal to conservative voters amid an ever increasingly warm Earth. to do a little bit of background on this, so when I came to OSU, 1998, I started hanging out with a lot of faculty and doing some research over in the College of Forestry. OSU has always had a long tradition of low silos, and I was interested in environmental politics and policy, and so I started working with folks over in the College of Forestry. And we put together an NSF proposal that looked at the role of science and scientists in the Northwest Forest Plan, Spotted Owl area. And this was conducted, it was myself, it was Denise Locke, who's an environmental sociologist, Bruce Schindler, who's a forest ecosystem social scientist, and Peter List, who was the chair of the philosophy department. In this particular project, we interviewed first and then surveyed all the research scientists that were involved in the Northwest Forest Plan, many of which were at OSU and U of W, and worked with H.J. Andrews, which I'll talk a little bit later. We also got a list of every single interest group that gave testimony. So from the timber industry, from the recreation industry, environmentalists, and those groups came in from all around the world giving testimony. And so we interviewed some of those, did surveys, and then we also interviewed and surveyed managers, so natural resource managers in that project, and then finally the attentive public, so the members of the public that gave testimony on the Northwest Forest Plan, but were not associated with an interest group. It was a very successful project, and that was a pilot project, and so in 2006 and 7, we proposed a larger project to NSF built upon the pilot study. And we basically we examined the 4 different actor groups that you see in the policy process, but we did this at a national level, and then 4 case study sites that I'll talk about a little bit later. And the leader on that was myself, and then Denise Locke, environmental sociologist, and Peter List, the environmental philosopher. After that, in 2011, we were contacted by a marine research organization and to replicate that 2000 study, but looking at Pacific and marine and ocean issues, starting with the North Pacific first. And we used the same methodology and approach to that. So once again, scientists, managers, NGOs, and the public in coastal states, and then also a case study in the Pacific, North Pacific. And then I went too far there. In 2017, then Erika and I took this research, these protocols and methodologies in place, and used them to look at other issues rather than environmental issues. So some of like immunizations and some other things that we'll talk about, teen sex, some things we'll talk about tonight. And we conducted a survey among the public on the West Coast states, California, Oregon, and Washington. And Erika will be talking, that 2017 study is the subject of our book, and Erika is going to be going into that more detail. The 2007 study included scientists who worked in the Northwest Forest Plan, like I said, and many of them were associated with H.J. Andrews, NSF Long-Term Ecological Research Site, and Oregon Central Cascades, which is heavily involvement by Oregon State University and our College of Forestry. The interest groups industry that were interviewed and surveyed were those that gave testimony on the Northwest Forest Plan, and there was a wide assortment of those. Interestingly, one of the groups that we interviewed was a group of motorcycle riders with Harley Davidsons that like to ride to the forests, and so they gave testimony on the Northwest Forest Plan, and a variety of other interesting groups as well. And we also interviewed all public managers in the Spotted Owl Northwest Forest Plan area, so state that worked for state agencies, USDA Forest Service, BLM, et cetera. And finally, the attentive public, what you talk about, people that show up and gave testimony. And I got a picture here just of the area that the Northwest Forest Plan incorporated. In the 2007 study, which is a follow-up to the pilot project in the Pacific Northwest, we did a survey of all NSF long-term ecological scientists in the United States. And so long-term ecological program is basically an NSF program that conducts long-term research like at the HJ Andrews. So we conducted a survey, all the scientists there on the role of scientists and science in the policy process. And then we selected 4 sites to do case studies with, and those included, because we wanted different socioeconomic context, cultural context, and ecosystem context. So we included Coweta, which is the LTR site in Appalachia, Central Arizona Phoenix site, which is an urban site, Savieta in New Mexico, and then North Temperate Lakes in Wisconsin. So different cultural contexts, different ecosystem contexts, different issues that they're dealing with. And once again, we did at each site, and then nationally, we interviewed and surveyed interest group representatives, managers, and did surveys of the sample surveys of the public at large as part of this process. The 2011 study, Marine Ocean Science Study, we were contacted and did a project for the North Pacific Research Board looking at the role of science and scientists and the grants that they give up in the North Pacific. And so we use the same methodology and the same approach there. And then we expanded it, and we conducted a national sample of marine ocean scientists working at universities with Sea Grant and state and federal agencies across all in the coastal states, not the Great Lakes. We wanted to have saltwater. We did a national sample of resource managers, NOAA, State Department stuff in all coastal states in the U.S. And then we did a national sample of interest groups that deal with marine and coastal issues, and then a national random sample of households from coastal states. And then finally, Erika is going to talk about this. Then we took the same methodology, the same surveys, and we conducted a random household survey in California, Oregon, and Washington states concerning controversial scientific issues, childhood vaccinations, GMO, climate change, teen sex, and stem cell research. And that project looked more at the impact of values and how people perceive these issues and their policy preferences. And once again, Erika will talk more about that. One of the things that we did in the pilot project is we developed a positivism index, and we did this first by interviewing natural scientists and social scientists and polling statements from the famous positivist Karl Popper, and we sent out a survey with like 70 statements to a group of social scientists and natural scientists, and we asked them, what would you consider positivistic or not? And then out of that list of like 70, we asked them, the majority of the scientists that said this is positivistic, we pulled that out and got rid of the other statements that didn't receive a majority. And then we conducted another survey, and we basically cut this down to 5 items that stick well together. So this particular project, we include this index in our book projects. And so this is the 2007. By the way, the results we got in all these projects, all these different survey projects and interview projects are fairly similar, on the year and the case study they came from. And so you can see from here, I'm not going to spend a lot of time on this because we don't have a lot of time to spend on the presentation, but you can see some of the statements here. For example, the first one, use of scientific method is the only certain way to determine what is true or false about the world. You can see that managers, natural resource environmental managers are least likely to agree with this. This is a 1 to 5 Likert scale where 1 strongly disagree to 5 strongly agree. And then fairly similar among scientists, interest groups, and the public. The second one here, the advance of knowledge is a linear process driven by key experiments. You can see that the scientists were the least likely to agree with that when compared to the other groups. I'm not going to go through all this right now, but some of the results we got in this and from all the studies is that from 2000, 2007, 2011, they indicate that there are statistically significant differences among the 4 groups in all five statements. And for the most part, the public and interest groups tend to have the highest mean scores of all groups, while managers and scientists have the lowest scores. So the public respondents and the interest group respondents are more likely to see science as positivistic when compared to managers and scientists, interestingly. Another thing we did based upon in the 2000 study was come up with a list of potential roles that scientists can play in the policy process. And these aren't necessarily mutually exclusive, but these are what came up from the qualitative interviews that we conducted and then follow it up with survey research. And so they start with a base, what we call normal science or basic science. Basically, what a lot of academics are rewarded for is basically publishing, getting citations, and then not getting too involved in things. And so it's a minimalist role. And then we go up to more what we call post-normal science, where scientists get out of the lab and start working with managers, working with policymakers to integrate the best available science in the process, the policy process or management process. So the next one is basically interpreting results for others involved in natural resource management decisions. And then next is work going a step further, is helping to integrate those results. And then we had a question on advocacy. Scientists should actually advocate. And then we have the final technocracy that basically puts scientists in control of things. Okay, you can see from most the results that we got, and this is pretty consistent in all the studies, most groups were very, very supportive of scientists reporting scientific results and then helping to interpret the results for natural resource management decisions or for policymakers. And then scientists should work closely with managers and others to integrate scientific results. It's very, once again, very, very popular. Not so popular for advocacy, and of course, not so much support for just making decisions itself. Okay, and so looking at back over this in general, most responses with exception managers showed the least amount of support for scientists taking a minimalist role. In some of our case study sites, the manager said, just give us the information and leave us alone. And I'll talk about, we have an anomaly on that in a second, I'll talk about. And then when it comes to scientists taking the advocacy role, scientists and managers tend to be less supportive than the interest groups in the public. The interest groups in the public were more supportive of scientists being advocates. And I'll just, and there was strong support once again for integrating and interpreting, having science working closely with policymakers and managers to integrate research. The one anomaly found in this, and this will be of interest to people here in the Pacific Northwest, when we were out doing interviews and conducting surveys, in the Pacific Northwest case studies, managers, natural resource managers were significantly more likely than other sites to prefer scientists involved in interpreting and integrating science into management, leading for a desire of cover. So one of the things we heard in interviews is because of how toxic a lot of natural resource environmental issues have been in the Pacific Northwest with the Northwest Forest Plans, Simon Wars, Old Growth Wars, Al Wars, that a lot of managers in the Pacific Northwest actually wanted scientists much more involved in the other locations we're at. And one person told me in an interview that it provided them cover, and another person told me that it moves the target from their back to another back. Okay, and then finally, this is a study that we did. So these are LTER scientists that deal with terrestrial science issues, management issues, and research. And this is a study we did with the marine ocean scientists, just to show you we didn't know what they would think about. This is asking the scientists themselves out of all these different roles. And I got a duplication down here in the bottom. Sorry about that. But we asked them what their preferred role is out of the 5 roles. And you can see there's not much difference. Scientists should help, policymakers and managers integrate science in the policy process, management process. In general, in the public samples in 2000, 2007, 2011, we found that self-identified conservatives were less likely to agree with the positive index, the separate items in it, the questions, and then the overall index. And we're much more supportive of a limited role for scientists in natural resource, environmental, and ocean coastal management and policymaking processes. And so I'm going to leave this now for Erika. So that's kind of a setup for what we've been doing, and Erika will take it off for the next study.
Okay, thanks, Brent. So Brent, if you can unshare your screen so I can share mine, please. Thank you. Okay. So yeah, so as Brent mentioned, a lot of this led up to what we produced in 2008, which was the book When Ideology Trumps Science, Why We Question the Experts on Everything from Climate Change to Vaccinations. And what we were really curious about in this is how values and worldviews can overshadow scientific consensus on the 5 issues that we looked at, which was climate change, vaccinations, teen sex, and in that we included the HPV vaccination, which I can talk about more certainly if people want to, stem cell research, and GMOs. And so we were very curious to see how these social issues, how these environmental issues all fell within this realm of the way that people think about them, as opposed to aligning with how scientists think about them or how a scientific consensus has sort of formed around these issues. So one of our sources that we drew from was the Pew Research Center. And as Nathan had mentioned initially, in 2015, there was a survey of scientists and the public. And what they found in here was significant gaps between the way scientists thought about certain issues and the way the public felt about certain issues. So there was an 18% gap between the public and scientists on the issue of requiring measles, mumps, and rubella vaccine. There was a 51% gap between public and scientists that felt that GMOs are safe to eat, where the 88% of scientists felt GMOs were safe to eat, compared to only 37% of US adults. And then when asked some general science knowledge questions of when asked whether the universe was created by the Big Bang, 52% of the public said that scientists are divided on that issue, while only 42% said scientists generally believe in the Big Bang. So the lack of public knowledge of science concerns scientists, with 84% saying the public just doesn't know that much about science, and in part blaming the media for oversimplifying the problem. But there's probably more to it than that. So one of the issues that we were looking at, or one of the things that we were most interested in, is basically how are people taking in information and then coming up with their own ideas about these various issues, where they take their policy stances when we again see that there's stronger alignment within the scientific community around these issues. So in the face of complex policy decisions, we would think that people would, once they kind of get new information, that new information would then sort of revamp the way that they thought about things to reflect their new acquired knowledge. And this normative model regarding decision-making basically implies a 2-step updating, beginning with the collection of belief relevant evidence, followed by an integration of new information with the prior to produce an updated judgment. But humans are complex, and we don't always comply with the rules of logic. So although people are always constrained to some degree to be accurate, they're also typically unable to control their preconceptions, even when encouraged to be objective. So motivated reasoning suggests that emotion-based decision-making basically obstructs the ability of individuals to assimilate new information that is contrary to their preferred policy positions, or what is known as a disconfirmation bias. And people seek information that conforms to their preconceived preferences, enabling a confirmation bias or an attitude congruence bias to occur when searching for information. And the obvious way to point to this, of course, if we think about where we get our media from, if you are more liberal or to the left, perhaps you get your media from MSNBC. If you're more conservative, you might get your news from Fox, because those views that you are taking in already mesh with the way that you see the world. And so it sort of reinforces your belief system and gives you confirmation bias of the things that you already believe to be true. So therefore, the information obtained is sort of demarcated deliberately to support existing policy preferences. And other non-conforming information is seen as not as accurate or scientifically sound. And this has been researched extensively in psychology, and also through some neuropsychology experiments where they took 30 partisans, 15 leaning more to the left and 15 leaning more to the right, and looking at an elections time, basically hooking them up to an fMRI machine and finding out what's going on in their brain activity when they're given information that is not particularly good about their candidate, or is something that they would have an adverse reaction to. And what they found is that most of the activity in their brain that was occurring happened in the part that really deals with emotion, more the hot cognition, and never really sort of got to the other part, the cold cognition of logic and reason. And that happened regardless of where people were on the political spectrum. It just was something that each person really did because they want to confirm their own inherent bias. They want to have that congruence bias. And so the focus of this study really looked at 3 different variables: political ideology, post-materialist values, and beliefs in positivistic science. And again, used to examine those 5 issues that I talked about. And as Brent talked about before, positivistic scientific position holds that the scientific method and the empirical data is critical in establishing scientific consensus because it provides observable, replicable findings. And in this view, science is the most reliable way to understand the world, and through this strict methodological research can identify facts or truth. In terms of political ideology, what we've seen specifically in recent decades is there's been a growing polarization between liberals and conservative regarding issues of science. And in particular, Mooney was popular for suggesting that the extent of this divide amounts to essentially a partisan war on science, with conservative Republicans outright denying the general scientific consensus on issues ranging from climate change to evolution. In a 2014 study by the Pew Research Center, they found that 42% of conservative Republicans and 30% of liberal Democrats perceive science as being liberal. So if you're a conservative, that might lead you to distrust science more, scientific findings more, whereas for liberals, it probably would have minimal to little effect. So we used, as I mentioned, a variety of sources to examine these issues, including reviews, policy advocacy, and interest group perspectives, both public pronouncements and written materials. And then we conducted the 2017 household survey that Brent had referred to in Washington, Oregon, and California as a basis for ascertaining the preferred role of science in controversial policy issues and respondents' attitudes towards several controversial policies. So we sent this household survey, and this is kind of getting into the nitty-gritty of our methodology here, using random address-based sampling and the US Postal Service computerized delivery sequence file. We generated 3,000 residential addresses from that, and we sent out a modified version of Dillman's tailored design method to send out our questionnaire format with multi-wave and online survey implementation. And the positivism index was used the exact same that Brent had just talked about, where they were 6 questions of agreement or disagreement, and then created a 6 to 30 scale, sort of 6 being low positivism on the scale and 30 being high positive belief, strong belief in positivism. And then in political ideology, 1 being very liberal to the left, 9 being very conservative or right. So looking generally here, it's just the first is to ascertain the public attitudes towards science and scientists. So when we ask the question of how well informed do you consider yourself to be concerning recent scientific discoveries, we find that more people said that they're somewhat informed, but about 42% said they're informed or well informed. But then the follow-up is, how often do you talk about issues related to science and scientific discoveries with your family, friends, or other acquaintances? We see that they're more likely to say sometimes or often. So then this gets down to asking now the public preferences for science and scientists and policy, and tying into the research that Brent had just talked about. What we find here is that the general preference is for across the broad survey group was that scientists should report scientific results and interpret the results involved in policymaking, or scientists should work closely with managers and others to integrate scientific results in policymaking. The least preferred options overall, where there was more disagreement, is that scientists should only report scientific results and leave others to make policies decisions, and that scientists should make policy decisions. They disagreed with that as well. So asked specifically, what's the best single description of your preferred role for scientists in the policy process? What they found is roughly it's fairly evenly distributed in terms of the interpret, integration, or advocate, but advocate comes out a little bit more of the number 1 preference. Now breaking it down to ideology and preferred role of scientists, how we look to see what's the difference between primarily liberal and conservative preferred roles. And for liberals, their preferred roles tend to be integrating results or advocate for specific policies. Whereas for conservatives, they're more for only reporting scientific results or interpreting the results for others. Looking at positivism beliefs and preferred role of scientists, those with sort of the lower level on the positivism scale tended to a little bit more lean toward reporting scientific results only, whereas those with high levels on the positivism scale were more for advocating specific policies. Okay, so I'm going to talk about a few of the issues that we looked at in the book, and we can certainly get into more of this later on. But one of the issues that we looked at was childhood vaccinations. And I have a couple of different quotes up there taking vastly two different positions on that. But in 1998, Dr. Andrew Wakefield published his findings suggesting a link between autism and the MMR vaccination. And although later this study was discredited and Wakefield lost his medical license due to misleading results in this study, his findings have planted seeds of doubt about vaccines and children's health. And the connection between the MMR vaccine and autism still rings out today. So all these years later, although the study has been pulled and he's lost his medical license, it still holds true that many people are hesitant to get the MMR shot, thinking that potentially there's this connection. So then we wanted to see what's the difference between ideology and then positivism, looking at vaccine orientations. And so the prompt being of some vaccinations can cause autism in children. What we find is liberals, 58.5% disagree with that statement, that they do not believe that autism causes children. And still more conservatives, although not a majority, 43.7% also disagree that vaccines can cause autism in children. However, when asked if there are serious side effects from vaccinations, what's interesting is liberals were more likely to agree with that statement, 40.7%, whereas conservatives were more likely to disagree, 47.2%. Turning to positivism beliefs and vaccination orientations, what we see is that people who are more on the low positivism scale are more likely to disagree, that say that they don't believe that vaccines can cause autism in children. And that is in contrast to 63% of people on the high positivism scale saying that they don't believe vaccinations cause autism. Looking now at whether or not there are serious side effects from the vaccinations, what we see here is that the disagreement, hang on, I lost my train of thought for a moment, that the low positivism scale, they agree that there are serious side effects. In fact, a majority agrees that there can potentially be serious side effects from vaccination. That's compared to a majority of people on the high positivism scale, 59.4% disagreeing that there could be serious side effects. And one of the things that I want to quickly mention about vaccines and why we asked about the HPV vaccine, but we didn't ask about it in connection with the MMR, is because the HPV vaccine tied very much into this conversation about teen sex and abstinence only. And when HPV vaccine was initially rolled out, it was rolled out as a sexually transmitted disease. And so for many of the, which it is, but for many of the parents who were taking in this information, they had hesitancy about getting a vaccine that would somehow be seen as encouraging sexual activity, or certainly having to think about that for your younger child at the time of getting the vaccine. So we put that together in talking broadly about teen sex and abstinence only education. And that folded in well with the way that people perceived Plan B or abstinence only education, and also HPV. So anything sort of sexually related to sexual health for teens was sort of lumped together in our study. So looking at climate change, what we see is that still a good majority of people of our survey, 80%, state that they do believe that there's solid evidence that average temperature on Earth has been getting warmer over the past few decades. And then asked whether they believe that the Earth is getting warmer because of human activity or natural patterns. Again, a majority, 67%, saying that it's mostly because of human activity such as burning fossil fuels. Looking at political ideology, what we see is that a strong majority, 90% of liberals believe that the Earth is getting warmer, whereas that's in contrast to 67% of conservatives. Again, that's still a majority of conservatives, but there is quite a divide there between those two groups. And then follow-up question of if they believe that the Earth is getting warmer, the reason why, liberals are much more likely to say, 85% of liberals, to say that it's mostly human caused, whereas the majority of conservative, 52%, would say mostly natural patterns. So when we look at positivism, we see some similar things, that people who are lower on the positivism scale, again, still a majority saying that they agree that the Earth is getting warmer, but this is compared to those in the high positivism scale, which is 86% saying that they believe it's getting warmer. And then looking at why that is, the majority in both of these cases still, either whether it's low or high on the positivism scale, both saying mostly because it's human caused, 59% for low positivism scale and 78% for high positivism. One of the other issues that we looked at was stem cell research. And so we wanted to ask the question about whether or not, sort of the general question first, of where people sit on this agreement or disagreement about using stem cells for research. So when we asked, is it acceptable? It is acceptable to use embryonic stem cells for medical research. What we find here is that about 70.2% agree or strongly disagree with that statement. Then this is interesting when it says medical research should use stem cells from sources that do not involve human embryos. What we see is a fairly even split between, I'm going to just say sort of three different categories here, where if we look at the agree and strongly agree, the strongly disagree and lump them together, and the neutral, it's all around the 30-some%. And so there was some discrepancy there about whether or not they felt that should not come from human embryos. And one of the interesting issues with stem cell research is really when it started to get a lot of attention, had to do with, in part, a big partnership between Michael J. Fox and between Nancy Reagan. And Michael J. Fox, of course, who has Parkinson's disease, and Nancy Reagan, who at the time, Ronald Reagan, was dealing with Alzheimer's disease. And so really trying to get the Bush administration to kind of get a little bit more impetus behind being able to use stem cells for medical research. Of course, our study was done much later than that, but that was sort of the turning point in terms of getting it a little bit more on the agenda and getting some political saliency behind it. But looking at political ideology, then, when we think about stem cell orientations, is both liberals and conservatives agree that it's acceptable to use embryonic stem cells for medical research. With liberals, again, there's about a 20% difference between the two, but with liberals at 78% and conservatives at 55%. Then looking at whether or not medical research should use stem cell from sources that do not involve human embryos, what we see is that liberals tend to disagree with that a little bit more, although not a majority, but 46.7%, compared to a slight majority of conservatives who agree that they should not use, that medical research should not use cells that involve human embryos, 51.4%. And then lastly, turning to the positivism beliefs, what we see here is that people who are low on the positivism scale also still agree that it's acceptable to use embryonic stem cells, and that aligns with people who are higher on the scale, but we see a split again, a significant split in the percentages. And then turning to medical research, whether or not they should use stem cells from sources that do not involve human embryos, we see the people that are lower on the positivism scale agree that they should not involve human embryos, but it's not a majority, it's 39%, versus 40% of liberals who disagree with that. Sorry, 40% of people higher on the positivism scale who disagree with that. So essentially, that's a very quick kind of snapshot at a few of the issues that we looked at, and certainly we can talk about more of them. But one of the underlying things that we did see, and sort of the takeaway of this, is that there's differences in issue orientations that are based on positive and political ideology. And the most pronounced differences that we talked about tonight involve ideology and climate change, and ideology and stem cell orientations. And so what do we do about this? Because we can look at what science is saying, and we can see where there's consensus, or at least there's agreement on issues. And then how do we sort of get people to the point of sort of trusting in the science, or sort of seeing that the science is being true or accurate? And part of the problem is again, for so long, I think we've said, well, we just need to educate more. There just needs to be more knowledge. And we realize now that that's not going to solve the issue. And that even this notion of correcting people's misinformation can have a backfire effect. So if you think about it, the person that you may have an argument about some, whatever the issue is, but it's particularly true within people who have vaccine hesitancy, is the more that you try to kind of discourage their vaccine hesitancy, the more likely they might really lock down in their beliefs. And that it can increase misperceptions. So we know that sort of this corrective information is not something that tends to be very helpful. One of the promising things that have been looked at is issue framing. And essentially where we maybe frame information in a way that resonates with ideological and value systems. What the issue becomes with that then is that it could also lead to a backfire depending on how you frame it. So they know, for example, that when we frame climate change as a matter of public health, that tends to resonate with people no matter where you are in your ideological and value system. However, when you frame climate change as a way of national security, that can actually make some people maybe on the right a little bit more hesitant of what you're saying. And so when we talk about issue framing, one of the concerns that Nisbet and Mooney certainly warn against is sort of this Orwellian idea of sort of like constructing a story around something or a frame around something to kind of, convey the idea. And people might feel a little manipulated into kind of going along with thinking about things. So that's something to be concerned about. But what I find really interesting is a study that's come out just recently by Kahn, who's at Yale. And in 2018, he had a study that looked at both scientific knowledge and scientific curiosity. And he found that those who score highest on scientific curiosity scale tended to converge on what the evidence signifies about climate change, private gun ownership, nuclear power, and other risk sources. And this leads to less polarized views. So what's really fascinating about this is, again, instead of sort of saying, because people can have high scientific knowledge and still be very disparate in agreements over whatever issue is being discussed. But when he finds that what the study found is that people who just are genuinely curious, who sort of seek knowledge for knowledge's sake and sort of just want to know what's going on. And in fact, one of the examples is they provided information to people during the survey time, and that they would see what people would choose to read or to look at. And people who chose to read about science stories tended to score higher on scientific curiosity scale. So they just wanted to know what was going on. And so all we have to do is cultivate scientific curiosity. I don't know how we get there, but it does lead to some, to some potential for being able to maybe have conversations that span across ideological or other types of value scales, and to really just asking the question of how can we be curious about something and want to learn more. And when they find that people do that, they can bypass that sort of that hot versus cold cognition part of their brain. So they can get out of emotion and those type of thing and really get into logic and reason. And when people are able to do that, we are able to like understand multiple sides and multiple perspectives and take information in a little bit better. So I hope I didn't go over my time. So thank you. And I will stop sharing my screen now.
All right, perfect. So I think I'm back on. Excellent, excellent. All right. Well, we're getting questions starting to come in. First of all, thank you both for the time. I think I've got a lot of questions spinning in my head, and I will definitely throw some out. But we've got a number to pick from right now. If you have not submitted questions yet and you are participating in our event this evening, just double check in chat, use menti.com on the screen, and you will have the code, the event code, to be able to put that in. And we ask that you pop in whatever question you like, and I'll moderate it as we go along, or you can just stick it in the YouTube live chat. So again, lots of them coming in as I'm going through here. Let's go question one. So is it correct to interpret anti-intellectualism as being low positivism belief, or is there more nuance? If so, how would you please comment on said nuance? And I think the way that we'll kind of take this is whoever kind of chime in, and if you guys have something to add, since it's the dynamic duo of you both tonight, feel free to do so.
Well, I'll start with this one. I wouldn't call it anti-intellectual at all. We have many colleagues here and on other campuses that are very skeptical about how positivistic science is, including, as you saw in the results, most scientists don't go that far. So there's this post-positive movement that, you know, science is dynamic. It's not necessarily linear, that there are different interpretations, different methodologies, and it's an ongoing process. So to be, and then our social science and humanities colleagues that are postmodern also are curious about the role of how science intersects with power. And so, I mean, it's more complicated than that. I think that's a good question.
Erika, any weigh in on that one yourself, or?
No, I would agree with Brent on that. I don't know if I see that those two are connected. I just think that it's, yeah, we're thinking about the world a little bit differently, even people who work within science fields.
And I might add one thing about that too. So I use with our students, I'm old enough now. When I took my intro physics class and my intro chemistry class, there were different theories on what light was. And I remember having to do my rote memorization for my exams. And now it looks like there's a synthesis. I know there's probably people on here a lot more knowledgeable than that, but I just think back about things I were taught where were scientific fact, and then we've found more information and we have different interpretations now.
Well, and kind of like what you guys were talking about earlier of people's perceptions of the linear versus kind of the multiple pathways that could intersect with additional research. So I think that's an interesting point. One thing that's come up, and Erika, you led a little bit to this, and maybe not exactly sure how we do this, but maybe some additional thoughts on how we can make science seem less biased or normative for folks, and maybe kind of even taking that a step further. What are some of those factors now, and I guess current life as it is, that are maybe making that even more difficult?
Yeah. So in terms of how do we make science less normative, or less biased, I don't know if I have an exact answer for that. I think what we can say is that I think that people appreciate both transparency. That's certainly an issue that's come up a lot, but also this idea of, it seems like as we were researching the book that where there seemed to be a lot of hesitancy around science and scientists was how they're funded and where the money is coming from and who's sort of behind what they do. And so I think that leads into the transparency thing. And I think that that's true when we looked at GMOs in this study. I think it's true when we talk about vaccines and big pharma and those types of themes that kind of kept emanating out of our research. So I think that there's some research that people don't necessarily think about as potentially as having more inherent bias or something in it. But then I think when we think about the controversial issues, that's where there's more of this like, well, who funded that study and what's going on, and what's the transparency behind it? Because we do know that things are ever evolving and ever changing, and what we maybe believe to be true isn't always going to stay that way regarding anything. If we talk about pesticide use, and we've seen the evolution of that over time with more scientific evidence, and even though at one point maybe smoking was once okay to smoke, and people didn't think about that in terms of public health. So these iterative things is just thinking about like who is doing providing the information, how is that being conducted?
Mm-hmm. Another good question that's coming in from Joseph from YouTube, and I'll kind of reframe it a little bit, but folks that are maybe non-scientists or less educated in science in general, having a hard time differentiating between anecdotes and data. I think there's probably lots of different reasons for that, but any thoughts on that? And Brent, I see you're kind of shaking your head on that one. What's kind of the biggest challenge between those two issues?
Well, I don't know if this is going to answer or not, but I think there needs to be, I'm just going to refer back to some things we've done on campus here. So we started a nonpartisan, nonprofit voter education NGO here back in the early 1990s called Vote Smart. It's called Project Vote Smart, but votesmart.org. And so it's a database of facts in a sense of, how candidates and elected officials have voted on bills, where they take their money from, their interest groups, rankings, and what their position is on issues based upon their previous behavior or a questionnaire we did. And so I think it's real important to have information available like that first. If we don't have that, then it's hard to get to the next question that you asked. And so I think, for example, on campus, extension service is an excellent example, and be able to take complex information, working with scientists, and then putting it in a format that the general public can understand. But then the next step then to get people to look at that versus anecdotes, that's a tough one. But one of the things, another thing that we've been doing on campus here in the natural resource environmental area, not in all areas, is what we've called KTAN, so knowledge to action networks or citizen science, then trying at an early age, trying to get K through 12 kids actually involved in research up through if they go to college, and then involving citizens as much as possible in research, in usable research projects that affect their life. I think that is a real key approach. We saw that in a lot of the case studies in the LTER projects, for example, in Phoenix and North Temperate Lakes, very successful projects like that, getting vast numbers of the students involved and the public involved. But that, I mean, that's just one approach that I've seen that's been rather effective. I don't know if that's not going to answer it, but it's been more of a process.
I don't have a clear, definitive answer to that also. I just know, again, from sort of drawing on research and then also just anecdotally from my life, really realizing where people are actually acquiring information and the way that we lock into that information. And it's very hard then to discern because of that same thing of what we want to believe to be true versus maybe what is, actually sort of in scientific agreement or something else. So I don't know if I necessarily think that either, other than of being able to teach how to be more discerning about information that we do take in. And I think that that's going to be critical. And I think University of Washington, if I recall, has actually run a program on that of how to even just discern information, because all of us don't have to be able to know how to read scientific findings and interpret that for ourselves. But what would be helpful is at least to be able to have a baseline thing of understanding when we're getting information that is not anecdotal and in fact based on maybe something that's research based.
Yeah, and I think one of the questions that came in was specifically kind of around this idea of if scientific theory was maybe taught in a different way, better way, whatever adjective you want to put on it in K through 12 education, people might merge into adulthood of having a little bit better understanding of like what's the baseline for determining some of that information and looking at science. And I think this is where it gets complicated for a lot of folks that say they don't have a science background, is this idea that you just talked about, Erika, of facts evolve based on the tools and the research that's advanced. So it's like what you just said, something in 1940 may look very different when there's new methodologies, there's new equipment that's used to kind of evolve that. So how do you deal with that facts can change because of advancement and getting away from the fact that science as a belief system? Because I think that's something this particular participant is asking the question around, is a lot of folks look at science as a belief system. Where do we go with that?
Well, I can give you an example. So I'm into hands-on learning here with science, and so some of the LTR sites actually, have K through 12 kids. They teach them collect data, to do biodiversity surveys, to test water, and even for this book project here, the 2017 study, that survey was partially designed and implemented by an undergraduate research methods class in political science at OSU. And so all the students in that class, when they got through it, they actually saw how things work, how you do samples, how you construct, try to construct non-biased questionnaires. And at the end of that, I mean, they're usable skills, but it actually changed their perception of the scientific process. And so I think involving people in it kids and adults is as much as possible is very important.
I don't necessarily think that we tend to circle around these ideas that what we land on then has to be the exact answer to something. And I don't know if we're kind of I might get in trouble for saying this, but almost sort of enough creativity in science, in the sense of saying like, it's okay to be wrong. It's okay to take different approaches and get there. As long as what we are agreeing to is sort of, at least some degree of like rigorous methodology and replicable findings and things that sort of resonate as being what we would all sort of agree to as being a more accurate way of seeing the world. So we might not be able to say exactly what's going to come of the results of climate change. We might not be able to predict those things. And I think for some people that makes it very very concerning, like, well, I want to know what it's going to look like in 20 years. But instead, I think that we kind of like rest back a little bit and go, well, what we're doing is, this is an iterative process. And it's a process that we need to maybe potentially invest a little bit more in, about how we think about having questions and how we try to get to answers, and how it's okay to be challenged on that and have conversations around that, and how that may lead then to a little bit more substantiated and a stronger sort of certainly a scientific consensus or a scientific agreement on that, and potentially translate that to the public as well on any issue, not just climate change.
Yeah, I mean, I think that translation to the public has been honestly like a question that's probably come up in a number of science pubs that we've done, of just how do we bridge that gap to make it accessible? And I think it's a little bit of a crisis of what I kind of call the headline readers versus the source finders. And it's kind of like the environment that we live in right now. It's a lot easier to look through your social media chat and find a headline that maybe agrees with your ideology, without necessarily taking the time to dive into it and where it came from. I think it's very interesting. You made the comment, I don't remember who, I think it was Erika, said around kind of understanding where the person's mindset came from before saying said statement or releasing said statement, and how it relates with how they've operated in their professional career or political career or whatever. So I find a lot, and I feel like a lot of people just don't take that time anymore, because the world has every year gotten a little bit more complex. And I think 2020 is definitely an example of that. So.
You're talking about a little bit, I'm sorry to interrupt you, Nathan, but a little bit of what Colin was saying in his research about saying we just need to be more curious. Like, instead of just seeing a headline, maybe if we're, that next step of being curious as to, I wonder why this is saying this, or where does this come from? And, trying to, we have to actively try to bypass our own biases. I know I do. I mean, Brent knows when we were writing the book, there was issues that we were discussing and talking about that I certainly had a moment of like, oh, I guess I sort of didn't realize I was locked into this way of thinking about something until really having to sort of step outside of my comfort zone of the things that I already believe to be sort of true in my worldview. So, so I'm sort of saying it's something for all of us to be able to think about a little bit more, about just being curious and go beyond the headline and go beyond just hearing these anecdotes, and maybe being a little bit more, just trying to be more inquisitive.
Mm-hmm. Yeah. Another question that came in, and I think it ties a little bit with the soapbox that I was just jumping on with the headline readers, but is there any good data that public confidence in science has diminished, and Steve is asking this, in the last decade? Any sort of study that maybe even looks beyond that, and what sort of factors may have contributed to the diminishment of confidence in scientific research?
Well, I'll let Brent talk about, but I was just looking up a bunch of the Pew studies and sort of their longitudinal data, looking at it, and they start saying that Americans still have a fairly high confidence in science and scientists. I think where it starts to branch off is where you get into issues then that tends to be controversial. I don't know if Brent wanted to add on to that.
Well, that's what we found in our own research. At a general level, we showed there's a high level of support, but then when you get down to specific issues, you'll find more polarization and conflict. Well, even here we go with an anecdote. So I have a very close friend of mine, a social scientist. I won't say where or anything, but on GMOs, he'll argue, well, I know they're healthy and stuff, they say right now, but I know the research is just going to come out and show that it's not. It's just a matter of time. And so very deep-seated ideological beliefs. And that's talking on not talking about where GMOs are sourced in the large multinational corporations and stuff, but we often run into things like that even among our peers.
Yeah, thank you for that. And so many of these questions I think tonight are going to kind of be interwoven. So I'm going to do my best not to repeat some things, because these are great questions. One thing I think you specifically talked about in the study is this particular question here. How do you respond to the statement, if you look hard enough, you can find a study that will support your point of view? For whatever questions you have both answers. So I think we talked about the evolution of studies and research, but Anything else that you might be able to add to that comment? So again, if you look hard enough, you can find a study that will support your point of view.
Right. Oh, go ahead, Brent.
I was going to say, it depends where you find it. So, if you're looking at a peer-reviewed scientific journal as one source, and then internet or social media or something's another source. So I think it depends where the source is.
Yeah, I also would say, like, I think, again, looking for more than just one, like where is it sort of, where are things sort of starting to cluster around, versus, oh, I found this one outlier study. And I think that was the damage with the Wakefield's study, is here he put out one study and he made this connection. And it was with a really small number of participants as well. And it just kind of blew up. And then from that, now to try to rein that all back in and to try to, make people feel more confident again in vaccinations, especially in the MMR vaccination, is challenging. And so I think what you want to look for is not just the one study, but you want to see where studies tend to generally fall. Where is it coming from? Because again, that gets to the other thing. If it's academia, or if it's from a think tank, or whatever this information is coming from, to sort of be able to ascertain that in your mind as well, about where you think, that more relevant or maybe more accurate information is deriving from.
Kind of also relating back to what we were talking about is the desire, the inquisitiveness, because, I had a science background myself, but I don't know that most people would understand even what a peer-reviewed journal is. So when they're looking something up, first, are they going to take the time to take a look at where it came from? And second of all, know how to even discern that or not. So I think that's adds another layer of complexity of what are we teaching, whether it's youth, young adults, whatever, how they're looking at that information. So thank you for that. Another one that came up too that resonated when you're looking for some of the charts with the positivism, please comment on the difference between scientific opinions and the opinions of people who happen to be scientists. In this particular participant's experience, their career working in government policy, they had to kind of sort through both. So maybe some comments on that.
Well, that's Erika, do you have it?
I was hoping you would take this one. I think that's hard. I mean, again, I think that's harder. I mean, when you're saying if it's a scientific opinion, I'm not sure what this individual's experience is, but I think that there's something different from someone who is a scientist saying something versus maybe a published or some sort of, more scientific opinion on how to do stuff. So, I mean, if you're talking about, whether you're conducting some sort of environmental assessment or whether you're doing something else, and that there is the scientific opinion in there, well, that that's derived from this kind of conglomeration of evidence that then they kind of lead to this. But again, and I think that there's, the cautionary tales of sort of speaking as a scientist and having that sort of just be what truth and knowledge is, and that maybe isn't always the case. And so I don't know if I have a clearer idea of that, except sort of circling back again to being able to see, well, is there, sort of a paucity of stuff that supports this idea, or is this grounded in research and other evidence?
That sounds like, yeah, versus political advocacy. Maybe that's what they're talking about, where the scientist has some kind of a policy agenda in place that may or may not be based on the preponderance of scientific evidence.
Mm-hmm.
Well, and I think that actually leads right then into another question that I think it's related. How important is it to assemble multidisciplinary teams to report and interpret scientific studies to the public so that you can minimize the risk of misunderstanding? So I think it sounds like this person's kind of hitting exactly on that point.
Yeah, I think it's extremely important. And a lot of the NSF projects that we've had at OSU and the ones that I've worked on have been interdisciplinary. And so that, they're really important because you have to learn the jargon of the other disciplines or what they mean. So for example, when I first started working foresters, they used the term disturbance, and I thought, what is disturbance? And it took me a while to figure it out and get an explanation of that. And then, okay, I got that now. And then, because I would have looked at it a different way as a social scientist, but learning how to, policy problems are so complex. Just looking at it from one disciplinary perspective doesn't give you the full picture. I think the the development of all the new interdisciplinary like NSF, NOAA projects is extremely important because it's not one discipline that can answer all these questions. You know, you're dealing with natural systems, you're dealing with humans. I mean, these things are complex, and having multiple perspectives is very important. And it also teaches you how to communicate better so that others can understand what you're talking about. So I'm a big proponent of that. And that's one of the things that has drawn me to OSU, because we've had, you know, I've been on projects, NSF projects and NOAA projects with people that are in 8, 9, 10 different disciplines, and it really makes you understand the complexity of things and how things are interrelated. So I think it's very, very important.
Yep. Without lowering our level of conversation too much, it reminds me of the scene in one of the recent Avengers movies where the cast comes in and they're asking Bruce Banner about quantum time travel, and Bruce's response as the Hulk is, "It's not really my field of study," but yet they expect him with the big brain to be able to answer all those questions in an area that he has no experience in. So it's funny as you say that. Of course, I go automatically to superheroes and the MCU. So thank you for that response. That's great.
Entirely relevant.
Let's see here. Now they're rolling in more. Here we go. Okay, interesting. So given that so much in policy debates is driven by competing and mutually exclusive values, are we not expecting way too much from science and scientists?
Well, that's a good point, especially in today's environment. But I think there are, we talk about this a little bit in the book, and then some other things that we do, and there are approaches. So Oregon is known for example, on natural resource environmental issues, on collaborative governance structures, where you're bringing in managers, you're bringing in scientists, and then you're bringing in all the really polarized stakeholders and trying to come to some type of meaningful agreement on how best to manage the particular issue that you're involved in. So I think there's approaches, but it's bringing others in, bringing the public in, bringing the stakeholders in, bringing in the people that are affected by the decisions. I think there's ways you can do that. What we've been experimenting with here in the state rather effectively. Not always, but I think there's sometimes. But I think that's a pretty good pretty good observation about where we are right now.
Next question from Brian on YouTube. Brian, thank you very much. Is there a political orientation divide between those who describe to safe unless proven otherwise versus unsafe unless proven otherwise? This person sees scientists on both sides of that issue.
So you're talking about risk and uncertainty.
Yeah, that's how I'm interpreting it. So Brian, hoping I'm doing a good job with that.
I haven't really, in a lot of this research, we've looked at risk perceptions, but we really haven't got into that detail that much. So I couldn't really comment on that. How about Erika? That's a good question.
Really good question. Mm-hmm.
That's a ponder one, and we'll put that out there in the interwebs later. Maybe that's the next research piece.
I might use that question in my class tomorrow morning.
Take it to them, and I want to know the results.
Okay.
Let's see here. So, any thoughts on using systematic evidence reviews, commonly used in medicine, to other scientific disciplines? It could be a useful tool to evaluate sometimes conflicting scientific information. I guess question, opinion, and a comment.
Yeah, I think that's a great idea. I know I've been on quite a few NSF review panels the last couple of years, and that's kind of what the process has been. It's been a very interdisciplinary process, multi-perspective process. So I think that there's a lot to that. I think that sounds like a very good idea.
And Brent, if I can ask you to expand, just because for those in the audience that maybe are not familiar with systematic evidence reviews, Is there like some like 3 big points or something like that that you would say about that process and what it looks like?
So so you have someone that wants to make a comment about that?
Their comment is basically, it could be a useful tool to evaluate. Sometimes conflicting scientific information is their comment.
Yeah, so I think that's, well, I've been on, so the grant review process is a little bit different than that, but I've been on interdisciplinary reviews that are kind of holistic when you're looking at the large picture, and they pose sometimes in the proposals, they'll have differing theoretical perspectives or perspectives in there that they're going to do the evaluation on. And so it's not quite systematic review, but I think it's the same kind of process. But I think those kinds of evaluations would be helpful. We're not there in the social sciences that I know of so far.
Okay, thank you for that. Looking at some of your research, this particular viewer is kind of looking a little bit differently. So how do scientists compare to other voices, such as politicians, newscasters, or religious leaders in terms of credibility with the public? So I guess I'm interpreting that as some of the things with positivism or any other pieces that maybe you use for your conceptual frameworks for your research. Has there been anything done with like kind of who's delivering the message?
Well, they talk about a decline in confidence in advanced industrial democracies, where, and there's a lot of theories on this and data on it, but there's been a decline in all what you would call experts, religious leaders, or whatever has been in serious decline in recent years. And one of them is value change, which is something we had in our study. We didn't present it tonight because of time, but there's this notion of post-materialist values that each successive generation has had higher levels of education, has become a little bit more cynical about the status quo and who's in particular charge. And so there's been a decline right across the board in pretty much all established elites. If someone's interested in this, the work of Ronald Engelhardt would be useful. He's originally at University of Michigan, and he's involved in what's called the World Value Study, which does every couple of years does surveys in 50, 60 countries and looks at generational change in terms of value orientations, attitudes towards government, attitudes towards religion, attitudes towards government. So that's so much. If you want to look at that, that'd be a good source. If you can send me an email, I can send you a huge reading list on that. But there has been in general a decline across the board. But as Erika said too, with the Pew Research Center, there still seems to be at a general level, abstract level, strong support for science. But it's just once again getting down to the specific issue.
And Brent, that's also a really good reminder too, just for the audience, that folks, if you have questions, I mean, feel free in your event tickets and then on YouTube in the descriptions. We do have contact information, and all of our faculty are readily available through email. So if there is a question that you have post-event, again, please feel free to send it to us at events@osu-cascades.eu, but also feel free to reach out to the faculty. Again, they're all very busy, clearly with lots of different things on their plate, but we try to do our best to get back with specific questions. If I can, let's maybe go with, looking through our questions here. Let's go with, and I'm jumping between my different portals here. For any of your studies, did they break out any of the responses based on any other demographics? In this particular case, this viewer is asking about results broken out by race. For example, there's very good historical, and this is their quotes in here. For example, there's very good historical reasons for vaccine hesitancy amongst African Americans. And the example they're giving is the Tuskegee syphilis study, which I will say I don't know much about at all. So I'm gonna trust the submitter on this particular case. But any comments on that?
Yeah, we looked at a lot of different demographic characteristics, and that's an excellent point. And a couple of our so in our graduate program, we have a lot of students from Pakistan, Fulbright students from Pakistan, and we were talking about this the other evening. And when they were tracking down Osama bin Laden, they used it under a ruse of a vaccination program in the area. And so now there's a lot of concern that that, we have this vaccination program going on again, and, people are wondering if who's conducting it, if it's real or not. And so, with the issue of Tuskegee and everything, I've been watching that on the news, like comments on the news like crazy about that. And so obviously that's extremely important. And there's other issues as well. So I just did a discussion with students last year, and I actually had a couple anti-vaccination students in one of my classes, and it's interesting because, my age, I grew up, I had measles, mumps, and rubella. It sucked. Sorry for that. But,
that's perfect.
Yeah. And so we were talking about that, and I said, I can't believe people wouldn't get a vaccination for that. And I got some real pushback on that. And, the pushback was that they hadn't really experienced, or hadn't been prevalent. And it kind of surprised me. I know this is a little bit off track, but I think, experience and then history matters on a lot of these issues. I think that's an excellent point. But we did control for a lot of demographics, and there were some impacts. There were some gender, some income and education as well, differences. And we could send that if anyone's interested, we could send that to them, the analyses to them.
And I want to add on to that, although Brent can send the demographic information and everything, but like one area that kind of comes out is always that there tends to be more women who are more in the vaccine hesitancy or anti-vax camp. And why that tends to be in some cases specifically related to the MMR is based off of potentially something that in the 1940s, when autism was first identified, it was identified in this college town where mothers were working at universities, and the researcher determined that the children had autism because of their cold mothers. This notion of refrigerator mother comes from that. And so when women are thinking about, and this is in part, like, not as much of this is in the book, although the refrigerator mother part is that when women are thinking about making decisions pertaining to their children's health, they also, and men too, but primarily still women are making the health choices in some cases, that they take on the burden of assuming whatever potential negative outcome comes from that as their fault. And in part, that's something that has been very much put upon parents, regardless, either way. And so of the people that I know who are vaccine hesitant, and again, it doesn't matter, mom, dad, whatever, and that they feel that if my child gets sick, if there's an adverse effect, it's something that I did wrong as a parent. I made a bad parenting choice, versus that, versus pointing to the evidence to suggest, vaccine injury is so exceptionally low, that something is more likely to happen from contracting measles, mumps, or rubella, or whatever vaccine preventable diseases out there. And so there's so much more to it, as opposed to, the scientific consensus or where, what's being told is being safe. And we see that now, currently with vaccine as well, is there's a lot of other things that are going on in the background that inform our decisions and our support for these different things.
Excellent. Well, you both, again, as we have the problem with every night, we can't get all of our questions. So folks that have submitted, sorry if we didn't get to your stuff tonight, but we really appreciate, first of all, everybody for attending this evening. And then Brent and Erika, again, your expertise, your ability to come here, work with the public, work in this setting to kind of spread this information. Really fascinating research. Again, encourage everybody to take a look at the publications that both have worked on together. And you guys have quite a library of other writings as well. So be curious for all of our guests. Get out there and learn a little bit more about this. Before we head out, a couple things. First of all, big thank you to our partners at OMSI, Terra Magazine, Oregon State University Events, and OSU-Cascades. And it is always a special shout out to our production team through Connect Central Oregon. Those of you that don't know, we have a student intern program, and they do a lot of behind the scenes work to make these productions happen. So really appreciate their efforts. A couple last reminders before we head out. Again, just with upcoming science pubs, we do have 3 more events coming up, our partner events towards the end of the month, and our OSU-Cascades specific events for Central Oregon later in the month. Lots of content coming up. February 19th is going to be the promise of 3D printing soft robotics. March 8th, the moral terrains of science, activism, and environmental justice. And March 17th's reschedule from our event at the end of January, Climate Change Impacts Around the Bend. So again, I want to thank everybody for participating. This concludes our Science Pub for Monday, February 8th, 2021. Tell a friend about your experience tonight. Shoot us topic ideas if you're interested in seeing something else virtually that we can put on for you. And we look forward to you joining us out there. Have a great evening, everybody.